Welcome to X1T Gaming, and together we're going to revolutionize the gaming industry. So, we are on lesson 6. We have done a lot, which is good. And now we need to go back to our prototype 1, which I think it's 3D car learning that I saved it under as. Yeah, and we're going to learn some stuff to kind of clean up the code a little bit better, make it more optimized. So, what they have is the overview. In this lesson, you will learn about a variety of different techniques to optimize your projects and make them more performant. You may not notice a huge difference in these small prototype projects, but when you're exporting a larger project, especially one for mobile or web, every bit of performance improvement is critical. Several of your prototype projects will have improved optimization, serving as examples for you to implement in your personal projects. So, from what I'm understanding, is there's going to be different variables that we're going to learn that will make the performance a little bit better. I guess there's going to speed some smooth stuff here and there. Um, yeah, it'll be exciting to kind of learn. Every little bit kind of helps out with the whole experience in the long run of things. So we're going to be learning those things. Um, they only have 3 sections to do. Oh, okay, so that's pretty cool. I think one of them is you duplicate your main camera. So then you have like different cameras to kind of work under. Okay, so we're going to do variable number 1. So we're going to open up prototype number 1 project to do our thing. Let me just switch over to this. There we go. So we got our car, if you guys remember, and this one still works pretty good. Go forward, back, rotate as you drive, and you could collide on things. It's a little bit slow, but that's okay. It's weird how it just rotates like that, but whatever. It works, it works. Decent. It's fine. Okay, so we're going to be working on. Oh, that's weird, the turning. That's weird, the turning. Oh, man. It's not like an actual car at all. So when I go, if I go like this, I'm going forward. Usually you want to go forward this way, and then you want to rotate and go backwards. But it rotates this way when I turn the wheel. It just turns the car. So if I want to go back, I just keep going the same direction to turn. I don't go left or right. I just keep going left. Oh, that's so bad. I wonder if I should like make it rotate the other way when I'm driving. Should I do that just for fun? Just be like, when in reverse, rotate this way. Maybe put some like if statements in there. And just go like, if I'm going backwards. How do I make it? How do I make the horizontal input go backwards? I wonder if I should just do like, it's like a rotate down. Yeah, if I press the down key, then we will rotate. You know what? Let's just do that for fun. Let's just do it for fun. Why not? We're here. See if what I am thinking actually works. So I want to put an if statement, see what happens. If we put the input dot get uh, get get button down, and then we do key code dot down arrow. So like that. Is it like that? I can't remember now. Transform dot rotate. Vector 3 down. Do it backwards. Time dot delta time. Time speed. Oh, turn speed is what I had. Times horizontal input. Okay, this one does not work. Key code dot space return backspace down arrow. What are some other stuff that they have? Oh, it is that down arrow that I want. I guess I can't do it because of the vertical input. Whatever, I won't save. Let's close it, don't save. It's going to spend too much time, and I want to learn some other stuff. Okay.
In this course, we've only ever used public or private variables, but there are a lot of other variable attributes that you should be familiar with. Now, I have prototype 1 open here, and actually what I'm going to do is instead of going anywhere in my scene, I'm going to go to my scripts. So I'm going to open up the scripts folder, and I'll open up my player controller script. Now, in my player controller script, I have all of these private variables. And if you remember, private variables can only be used within this class, and they can't be seen inside of the Unity editor. If I select my player object in my scene, in the inspector, underneath that player controller script component, you can see that none of the variables can be seen. In Unity, we actually have a very helpful variable attribute that you can use to see any private variables that you want to interact with. So I'll go to where my speed variable is created, and if I type a left square bracket, capital S, and write the word serialize, no spaces, capital F for field, and then I use a right square bracket. So now we have this serialize field attribute on our speed variable. What exactly is this doing? Well, if I save my script, and now when I open up Unity, you can actually see that under my player controller script with my vehicle selected, you can see that this speed variable pops up. So serialize field is a really helpful way of defining which variables you want to use just in the editor, but you don't want to ever use in a different class. So for example, if I have another class, another script that was using player controller, I want to be able to change the speed value in Unity, but I don't actually want to change that speed value in the script that's using player controller. And so that's a really helpful way that you can use serialize field to just edit variables that you just want to use in Unity itself. Just to show another variable that we can do this with, I'll also add this attribute to the turn speed. Make sure I save, jump into Unity, and now you can see turn speed can also be seen here. Now, if I open up my follow player script, in follow player, I can actually add this serialize field to our offset. Save this, head back into Unity, and select my main camera. You can see now I can actually see that offset from my follow player script, and I can actually change this to whatever values I want. In fact, if I actually play this here, so now our script is running, I can actually move my camera to get different perspectives. So that's just a very helpful way of being able to change any of your variables without using public. Other cool things that I can do is change this private keyword. So originally we had public as another variable keyword we could use, which means that we could see this variable in any other script that used player controller. You can also use the keyword protected. And so protected is a mix of private and public. So with private, I can use this variable in this script, in this class, but I can also use this variable in any other script that actually inherits from player controller. So for example, player controller inherits from mono behavior. And so you can think of start and update both as protected methods, allowing us to use them in our player controller script. However, if we made a brand new script that didn't inherit from mono behavior, we wouldn't be able to use these methods. So protected allows you to see variables or methods outside of the current class, but only to any script or class that inherits from this main class. Other keywords that we can use as well are words like const. So in this case, private const float speed. And const is just short for constant. And so that means that we can never change the value of speed because of this keyword. So for example, I could not write speed equals 10 and start because speed is a constant variable that can never change. Other keywords that you can also use are words like read-only. So when you first instantiate an object and use the read-only keyword, you can set that variable when you create that object, but then you can never change it ever again, versus const is defined as soon as you create that variable. And static is another keyword that you can use if you want to have something like a global variable to use anywhere in your code at all times. So I highly recommend looking up what the different keywords like protected, private, public, read-only, const, static, serialize field, see what they all do, try to use them in your code, and try and do some exploration yourself. So what you're going to do is open.
Okay, so yeah, no, it's interesting seeing all this different stuff. I don't know if I'm ready for that one. It's a little bit confusing. But then it's also not constant. You want a constant, but like why would you want a constant? I don't see a scenario where you would want like something that's constant. Maybe I do. Maybe you need something constant because you're going to have something else that's going to go back and forth, and you don't want that to interfere with it. Okay, maybe I can see that. Interesting. And then we got, what was the other ones? You have read only. I think that's self-explanatory. And static. Static, I understand what that one was about. Yeah, I'll have to go look through that stuff again. Okay, so now we're going to watch the next video. 2 more videos and then we're done for today.
In the course, we only ever use the default update and start event functions, but there are others you might want to use in different circumstances. In prototype 1, you can see we have our start and update functions that are used when our game is started and then run while our game is playing. So when I press the play button in Unity, any objects that have scripts will then use our start method, and then as our game starts to play, it will start using our update method. To learn more about why these different event functions are important, we're going to make another camera. So I'm going to right-click on my main camera in my prototype. I'm going to duplicate it. So now we have main camera 1. I'm going to actually rename this to be secondary camera. So this will be the camera I use when I want to get the view right in front of our vehicle. I'm just going to disable my main camera by selecting it, going all the way to the inspector and clicking on that little blue checkbox. So now it's unchecked and it disappears from our view. You can see the camera preview went away. So I'll select my secondary camera. Now you can see the view here, and I'm going to put it right in front of our vehicle. To do that, I'm just going to actually drag it into position here based on my camera view. There you go. So that's kind of cool perspective. You can kind of see the hood of our vehicle. And now I'm just going to take those values in the transform components and change the offset values from our follow player script. So now if I press play, and as I move along, you can actually see, as I'm driving this car, it's actually starting to jitter a little bit back and forth. And that definitely doesn't look very good. I could probably actually reposition this camera, but we'll keep it for now. And then as I run into these boxes, you can see the weird effects happening as I hit the boxes and actually colliding with them. So this is where knowing how to use event functions is incredibly helpful. Now, there are 2 event functions that we need to pay attention to. And this is all important for our update method. So update is one kind of event function. However, if we actually type the word fixed before update, we now have the fixed update event function. Now, fixed update is especially useful when you are trying to do movement and physics. Fixed update is actually called before update calls, and actually happens when our game is trying to calculate any kind of physics that is happening when we're playing it. So if I save that, we'll then go into our follow player script. Now we're going to do something very similar to our update method, but instead of using fixed update as our event function, we'll use late update. Late update is particularly useful when we're trying to calculate the camera's position. And so you typically want to use late update when you have a camera that follows the player. That way our camera knows that all of the calculations for our player's movement is done, so this is definitely where our camera should go as the game is updating. Now if I save this, head back into Unity, I'll press play again, and now you can see that our camera, from this first person perspective, isn't really moving around anymore, which is awesome. It's not doing that shaky back and forth motion. And you can see when we hit these boxes, we're getting less of that rumbling effect when we're hitting them, and it's a lot smoother as we hit each of these different crates. So those are two powerful ways that we can just make our game a little bit more optimized. One last thing that we can do is in our start method, just to see a different method we can use, we can actually use another method called awake in place of start. And so start is useful when you have certain objects that are supposed to do something as soon as the game starts. However, there may be certain objects that you want to only do something when you want to use it. So for example, if you want a wall to move, you could use the awake method. So somebody presses a button, it will then call the awake method for that object, that wall, and then it will do something. So if there's certain values that you want to make sure are created when an object wakes up versus when the game starts, you can use the awake method. We're not actually going to use start or awake at all, so we can actually just remove them. That way our code is a lot cleaner. We'll save our follow player script. In player controller, we'll get rid of our start method. And so that way we don't have to get confused when we look at our code and see that we have two empty methods that aren't doing anything. So what you're going to do is in prototype.
Okay, so that one I understood a little bit more. So we have the fixed update. I don't understand fixed update actually. After I said it, to know it more. But the late update, I understood. I think he actually went over that in the thing, was for the camera to see it. Because I think before the late update, it was going like this, the camera, and then once you have it, it made it more smooth. It was to move the camera first and then update, rather than update constantly and then you see the camera going back and forth. I think that's how it was like. And then the awake, that was pretty interesting to learn that one, because there's some things that you want to be in the start method, but you don't want them to be activated until they're activated. So it's an awake kind of thing. So that's pretty helpful. Okay, so we got one more, and then I think we are done. Oh, we gotta sign in. Okay, object pooling. So we're going to open up our prototype 2. Right, is it prototype? Let me double check. Prototype, open prototype 2 and create a backup. Okay, where's my prototype 2? Okay, and let's go and see what this video is. So delete the detect collisions, player controller, and destroy out-of-bounds scripts from your project. Download the object pooling Unity package and import your scene. Okay, so we'll see this last little thing for object pooling. I might have to pause it. It's not loaded yet. Slow computer. That's what you get when you have an old computer. But it's cool that you're going to be able to see this one day. see me go through this process, and I'm able to do this with an old, like a 10-year-old computer to get this stuff going. Of course, once it's feasible, I'm going to be upgrading my computer as soon as I can. Um, but yeah, gotta start somewhere. Okay, last video.
Throughout the course, we've created a lot of prototypes that instantiated and destroyed objects during gameplay. But there's actually a more performant and efficient way to do that called object pooling. So first you're going to open up prototype 2, and we're actually going to create a backup of our project. So I'm going to go up to the top menu, select Assets. I'm going to Export Package. Export. Now I'm actually going to export this package to my Create with Code folder. I'll call it Prototype 2 Complete, and I'm going to click Save. Now, we'll actually be overwriting a lot of our old work to use this new system, so it's important to make a backup first in case you want to revert back. Now, the idea of object pooling works by creating a reusable pool of objects, a set number of them, that can then be activated and deactivated as they are created and leave the scene, rather than instantiating and destroying our objects, which means that our computer actually has to do more work to create a brand new object and then delete it. So using object pooling is much more performant by just having a set number of objects and then activating them or setting them inactive when we don't want to use them. In order to do object pooling, we'll actually import the object pooling package into our project. So on the webpage for this tutorial, you should see a direct download link for the object pooling Unity package. Make sure you download it. Now, you can add the object pooling Unity package any number of ways. I'm actually just going to do it using the Assets option in our menu, going down to Import Package, Custom Package. In my Downloads folder is where I saved that object pooling Unity package. So I'll select it and import it, and you can see that there are a couple of changes happening with Detect Collisions and Player Controller. So now if I go into my Scripts folder, you can see that Destroy Out of Bound is here, Object Pooler is here, Player Controller has updated. So first we're just going to double check and make sure that all of our different objects are set up properly. So you can see because of the change we made to Player Controller, it actually removed our script, so we just reapply that. On Spawn Manager, our Spawn Manager script is fine. And we're actually going to add the Object Pooler script to the Spawn Manager. So I'm going to left-click, drag it, and I'll just drop it into the inspector. So you can see here now that there's a similar thing happening where we have pooled objects, we have objects to pool, and we have an amount to pool. We won't worry about the pooled objects right now, so we'll just collapse this option. The object that we're going to pool is actually our pizza. So if I go to Prefabs, I left-click and drag pizza onto that little slot. And now I need a number of pizzas to pool, so I'll press 20. So now when I press play... Oh, interesting. It looks like we're getting some errors down at the bottom here. That's kind of weird. Let's see. So the reference script on this behavior is missing. So it says the animal dough, and it actually says it for all of our different things. Let's see. Interesting. So we're missing a script here. Now, from what I can see we have our move forward and we have our destroy out of bounds, but we actually don't have the detect collision script anymore, so I'll drag it onto there. See if I select this moose, so they're all missing it, so I'm just going to apply all of these real quick. So now we can detect collisions. So when I press play, you can see in the spawn manager now, there's actually this expanding arrow that you can see all of the different food that we're pooling. And I'll go off to the side, and I can actually, you can see as I'm creating all of these pieces of food, it's actually setting them active and then setting them inactive as they leave our scene. And so now, we're not just creating and deleting an infinite number of pieces of food. We're only using as many as we need to use. So that way they're all created when the game starts. And then we don't need to ever delete them because we're just setting them inactive, but the player doesn't know any different. Now it's your turn. So you're going to open up your prototype.
Okay, so that was easy. Yeah, that's it for today. Yeah, programming level 4. Nice. Nice. Okay, so yeah, we're just doing some little stuff, learning here and there to make things more optimized. I guess it makes it more easier to have this object to pool. That's what I did wrong. Yeah, I want to see what the code actually is for the object pooler. Because then if we look at it, we could probably, instead of exporting it every time, we could maybe make it ourselves. So shared instance equals this. Okay, so let's see, all this stuff's public, integer, game object, list of object. This, okay. Pooled object equals new list of games. So this one increases each time that it's used. So you instantiate this because it's a 4, and then you got. Oh, this is interesting. Okay, loop through list of pooled objects, deactivating them and adding them to the list. Okay, set as children of spawn manager. Nice. Okay, so we're going to call that a day. We're going to do point to tomorrow. Yeah, you guys have a good one. I am on every day at 9 p.m. Pacific Standard Time, and my game that I'm making should be done by the end of the week. That'll be interesting. Yeah, if I can get it done by the end of the week, I gotta do a background. I gotta add some music to it, and then once I got all that, it's pretty much completed the game. I decided to go with just one level rather than easy, normal, and hard mode. Yeah, and then what I need to learn after that is to know how to put an ad on it and how to get it onto Google. And once I could get it onto Google Play, then people can play it, and hopefully I can get paid for it, and that'll be like a nice side gig. And then eventually it'll be nice to make enough games where I could do it full time rather than have to work. And then it'll be nice to make enough games where I can start to hire people to make more games. And then it'll be nice to make enough games to to be able to start creating really good content, high quality games, so that you guys can start playing, helping other people. So it's a process that it's going to go, but this is the learning steps at the beginning. And once that happens, who knows? Like, sky's the limit, I guess. And yeah, so I look forward to working with you guys, to seeing you guys. Send me your thoughts and prayers so that I could get this figured out.